Today we are doing the law of cosines, and the formula for the law of cosines is much more complicated than the law of sines, but it's actually really easy to memorize. Cosines, yeah. So the law of sines is very simple, right? So the law of cosines, and the law of sines applies to any triangle, right? It doesn't, the shape of the triangle is not important. However, the information that you have on the triangle is important because sometimes the information you're given won't work. So, for instance, if I had this, well, let's do. Can you use the law of sines to figure out how big the angles are? No. Why not? We don't have any angles, and in order for the law of sines to work, I need 3 of these 4. So I need 2 sides and an angle, or 2 angles and a side, and they have to be the correct angles and sides. They have to match up. So we cannot solve this using the law of sines. We need a new formula. Yes? Yes. 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 So these functions contain all of the information regarding side lengths and angles of a triangle. That's what trig is. So you could make a table. It would be infinitely large. It's a lot easier just to use your calculator to figure them out. So this is what the law of sines looks like, cosines looks like. A squared plus b squared minus 2ab cosine of c is equal to c squared. Oh, that's terrible. But it's really not that bad. Okay? It turns out this is not the only formula. There are actually 3 law of cosines formulas. And if you know one, you know the other 2. And if you know the Pythagorean theorem, it's really easy to come up with this. So how does this work? Well, we have to label our triangle. Actually, let me draw a different triangle. So A, B, C, A, B, C. Okay? So what that is saying is the sum of the squares of 2 of the sides is equal to the sum of the square of the third side with this information in there also. It looks a lot like the Pythagorean theorem, right? Well, it turns out the Pythagorean theorem is a subset of the law of cosines. So if this is a right angle, and I told you that B was 10, and let's do some 6, and A was 8, let's plug everything in the formula and see what happens. We get 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 90 equals c squared. But what is the cosine of 90? So think back to your unit circle. Cosine is x, sine is y. Where is 90 degrees? Right here. What is the x value at that point? 0. So what happens to this? It all goes away. And then we just get 6 squared plus 8 squared equals c squared. So the Pythagorean theorem is the law of cosines for right triangles. So the law of cosines is kind of a bigger formula than the Pythagorean theorem. When c equals 90, then the law of cosines just turns into the Pythagorean theorem. Okay? All right. So let's do something that is not a right triangle. Let's say we have 140, 8, and 10. And we want to find, we'll call that C. How do we figure out what C squared is equal to? Well, we just plug everything in. 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 140 equals C squared. Okay, and notice A, B, A, B, C. Okay, that's kind of how you can remember this. So I plug all that in. 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 140. And I get 286. So 286 is equal to C squared. I take the square root. So the square root of the answer, and I get 16.9. Is that a reasonable number? Yes. Why is that a reasonable number? It's bigger than all the others, and 140 is larger than all the other angles, so that works. But what if I tell you that A is 50 and C is 25 and angle A is 19 degrees. Oh, that's not what I wanted. Sorry. There we go. How do I find the missing side? How do I figure out how big side A is? So I draw the triangle. Does the shape of my triangle really matter? No. But if I put 19 here, then this side has to be A. And then this could be 50, and this could be 25. Will my formula work? No. Yeah, I have the wrong angle. So it turns out there are 3 copies of this formula, and they're all sort of interchangeable. So another version of the formula would be B squared plus C squared, and then what goes here? B times C times the cosine of the side, the angle matching up with this side over here. Okay? What's the other formula? C squared plus A squared minus 2AC cosine of B is B squared. So really, if you know one formula, you actually know the other 2. So I'm going to plug all of this into that equation, and I'm just going to type it in my calculator. So 50 squared plus 25 squared minus 2 times 50 times 25 times the cosine of my 19-degree angle, and I get A squared equals 761.2. If I take the square root of that answer, I get 27.6. Does that seem reasonable? Yes, 19 is a really small angle, so it should be across from a really small side. But it looks like this angle is actually going to be a little bit smaller than 19, so angle B is enormous. But anyway, that's just what happens. Okay. That's what you do when you're given side, angle, side. So think back to your geometry days. Side, angle, side. Okay? But what if you're given something like this? Let's do 30. And no, actually we don't want to do that yet. Sorry. And let's say I wanted to find all of the angles. Well, we have to pick one angle first. So let's focus on angle A. Which formula do we use for angle A? The equals A squared formula. So this is going to equal 18 squared. Okay? So what would the formula be? 15 squared plus 29 squared minus 2 times 15 times 29 times the cosine of angle A. Okay? Now, kids make a lot of mistakes here. So 15 squared, oh, that's 225. 29 squared is 841. So 225, 841, and then 2 times 15 times 29 is 870. And is that 2, 3? I don't remember. What is 18 squared? 324. Okay. Here's where the mistake comes. We need to move this 225 to the other side, and the 841, and the negative 870. So, how am I going to move this? Subtraction. How am I going to move this? Subtraction. That's going to make my answer negative. Is that okay? Yes. How do I move this? Don't add it. Division. Yeah, it's multiplied by the cosine. A lot of kids see the subtraction and think, oh, we add, but this is not what we're worried about. It's that connection. We want to undo the multiplication. So 324 minus 225 minus 841, and then divided by 870, negative 870, and I get 0.85. So the cosine of A equals 0.85. Now what? Inverse cosine, and I end up with 31.47. Any questions about that? Okay. We did c squared plus b squared minus 2cb cosine A equals a squared. So there are 3 copies of that formula, and you just pick the one that... No, and we'll get to that eventually. So today, everything is the law of cosines. But in the future, you'll be given a problem, and you'll have to think, uh-oh, will cosines work or will sines work? And they don't both work. It's one or the other. So if you try one and you don't have the right information, then you just use the other one. But we're not worrying about that today. And what dictates the formula you choose? It's the angle. The formula is totally dependent on the angle. So if you know which angle you're looking for, that tells you which formula to use. On the other hand, if you have an angle and you're going to use it, that tells you which formula to use. Okay. Now, that was a long process, right? Do I want to do all of that over again to find C? No. Use the law of sines. So you never have to use the law of cosines more than once. If you do it once, you will always have enough information to do the law of sines. So if I want C, I'll just say the sine of C over 15 is equal to the sine of 31.47 over 18. And that will spit out an angle, which is like 45. Once I have that, how would I find the third one? Yeah, just do the triangle angle sum. Okay. All right, let's take a look. So here's a triangle. A is 50, B is 30, and C is 28. Well, no, I think there are only 7. So it doesn't matter which angle you start with. So let's start with B. And that means that will equal 30 squared. Okay? So 50 squared plus 28 squared minus 2 times 50 times 28 times the cosine of B. So in my calculator, we're going to have 30 squared minus 50 squared minus 28 squared. And then I'm going to divide that by -2 times 28 times 50. And that is my ratio. That's the same as the last ratio. So I invert the cosine of the answer, and I got 31.6. So angle B is 31.6. And notice it says round your answers to the nearest tenth. So don't push second answer when you do more calculations. Leave it at 31.6, or your decimals might be a little bit off. Now we just do the law of cosine, or the law of sines. So the sine of C over 28 is equal to the sine of 31.6 over 30. So that's going to be 28 sine 36 over 30. So 28 sine 30, oh, what was it? 31.6 divided by 30. And then I invert the sine. There's my second angle, and then I just subtract both of those angles from 360 to get my third angle. Okay, that's problem type number 1. Number 2. Oh, really? Basically the same problem, but you don't have to do as much work. Are they going to give you... Okay, here's a side angle side problem. So here we have 2 sides and an angle, and we need to find the third side. So I could call this, say, A. So 220 squared plus 126 squared minus 2 times 126 times 220 times the cosine of 70, and that equals A squared. These problems are actually easier to do. All you have to do is plug them all in. So 220 squared plus 126 squared minus 2 times 220 times 126 times the cosine of 70. And that is equal to A squared. Then you can just square root the answer. And there we go. Okay? Now, there is a little bit more to this. There is one type of triangle we haven't talked about yet, and that's where it gets really, really messy. So stay tuned. Okay, get to work.